Hi, I just wanted to welcome everyone. Just doing for the tech drop-in. This is something that the Megaport Solutions Architect team does on a weekly basis. Um, so yeah, just here to kind of spread some knowledge and maybe help you out with something that you might be working with. So today I'm gonna kind of focus on route manipulation on the MCR. So as a little bit of a background, the Megaport Cloud Router, the MCR, is just kind of acts a UI-based router for any kind of cloud to cloud or cloud to site type of routing that you might have. It's intended to be just a pretty lightweight device that allows for, you don't have to be a CCIE. Heck, you don't even have to be a CCNA to set up BGP on a MCR. It's just, we kind of walk you through the process, get things going, and just set it up. I guess I could introduce myself as well. My name's Ryan Schrader. I am a solutions architect based in kind of the San Antonio, Texas area. And yeah, so just here to help like where I can. So, as mentioned, you're doing some route manipulation on the MCR as just a little bit of a demo. So what you kind of see in front of you is what I already have set up. So ultimately, I deployed an MCR in the Ashburn region. And then I also set up an Azure VNet with just a single VM there. Nothing exciting, just a single VM that connects to a VNet gateway that connects into an express route circuit. At the same time, I also set up a VPC in AWS. Again, nothing exciting here. It's just a VNet, I'm sorry, a VM that's inside the VPC. That VPC connects to a direct connect gateway. Only difference here is we actually have two different paths available. We ultimately set up a red zone and a blue zone connection, and then two direct connects coming into the MCR. So with that kind of configuration, ultimately we have three VXCs, one going to Azure and then two going to AWS. In addition to that, like by default, there would be no MED or no AS prepending, nothing set up on the device. So by default, we would actually be ECMP load balancing both towards and back from AWS in this kind of environment. So what I ultimately set up was I set up an inbound med of 100 on the primary. And then also I did a prepend of 5, whereas the secondary that I want to be a backup, I did a med of 200 and a prepend of 10. So, with med, always the lowest med wins. And then at the same time with AS prepending, the lowest AS path wins. So kind of to show you how this is set up in the Megaport portal, can come over here and, the diagram I just showed versus this, it's the exact same thing. So this is an MCR we have deployed in CoreSite in Reston, Virginia. At the same time, we have our two AWS connections and our Azure connection. Nothing too incredibly fancy. And at the same time, let me go ahead and switch over to our VMs that we have set up. So this is our VM that is located. Oh, and we just got kicked off. So let me get back on there. So this is the VM that we have located in AWS. And at the same time, then we also have our VM in Azure. Single device each side. And if we wanted to actually send a ping across between the two devices, let's just go ahead and get that in there. So you can see in fact, you have about 3 millisecond round trip time between, Azure to AWS. And us, honestly, that's one of the really important things to note about the MCR is just ultimately we have cloud to cloud routing available to you at 3 milliseconds apiece. But what we're actually not really worried about, but wanting to demonstrate is the fact that we are doing some route manipulation here. So let me go ahead and cancel out my ping, and then let's do a trace route. So it's not going to, from AWS to Azure, it's actually not going to complete going past this hop just because of ICMP rules inside of Azure. But the important thing to note is on this third hop, 10.10, that is my primary Azure, primary AWS peering. So traffic is going out we're from Azure, hitting the MCR, and then on the MCR, it is taking the primary path, which is exactly what we would expect it to do. At the same time, we can also look at the reverse path, and at the on the AWS side, and maybe we'll do an MTR here. So sorry again, my got kicked out there. So the exact host we're going to. Sorry, I had this prepped and then I got kicked out. So here's our host that we're going to. So let me go ahead and do that. Let's just set up an MTR. So here you can see, in fact, this actually finishes the trace route. So we're going from, this is from our AWS instance, hit a first hop. We actually are hitting the primary path. And then this is actually the AWS side of the primary path. This is the MCR side of the primary path. And then here we are getting into Azure. So you can see, based on this diagram, both inbound and traffic is taking this primary path as expected. But what if we wanted to have a maintenance? So, this is an active standby kind of configuration. Maybe we're preparing for a maintenance and we want to shift traffic over to the secondary path. So let's hop into the Megaport portal and make that change. So ultimately what we want to do is poison this path. You kind of had two options. You can poison this path and make it less preferred, or you can go into the secondary path and make it more preferred than the other. I just realized in my planning, it is worth noting in the MCR, the maximum you can do is a prepend of 10. So I actually planned a little poorly there. I had a prepend of 10, so I can't go and make the primary a higher prepend. So what I'm going to do is just make the secondary path more preferred. So let's go ahead and hop into the portal and make that kind of a change. So within this device, so I want to make the AWS secondary path more preferred. So let's just go into that peering and then go into the AN settings. And then from there, we have the option to make changes to the BGP connection. So let's just go ahead and hit edit. And the advanced tab is what we're looking for. So you can see I mentioned, doing AS path prepend of 10 and then a med of 200. Going back to this, that is exactly what we had set up. So let's go ahead and change that to a little bit more of a preferred path. So instead, I'm just going to do, in fact, I'm going to do no prepend. And then let's just do, super low med of 10 or value of 10. So it is worth noting that this is kind of manipulating two different directions of paths. Whenever we're talking about the BGP paths, advertisements that are going out towards AWS. So that actually, by doing a AS path prepend of 0, just using the native path, we are influencing traffic from AWS towards our MCR. And at the same time, doing the inbound med. I did both inbound and outbound, but ultimately what we're worried about is the inbound med. So by manipulating the inbound med, we're telling the MCR, even though I'm getting traffic from two different AWS paths, I have a inbound med of for this secondary of 10. So that's going to be our best path. So basically, we're manipulating with prepend, we're manipulating inbound from AWS towards the MCR. And by changing the inbound med, we are influencing MCR towards AWS on a data plane path. So I'm going to go ahead and hit update and then go ahead and hit save down here. So this is where we get to the fun part, where it takes about 2 to 3, maybe 4 minutes for this change to actually take effect. But we're going to leave this MTR running. So here, like, honestly, it'll be about 2 or 3 minutes before we actually see a change here. So, somewhat we'll try to not make this look like paint drying, but kind of let me just show you some features that are on the MCR while we're waiting for that to happen. So ultimately, you kind of mentioned, making some changes into that BGP peering. One way that you can see the state of the MCR while you're waiting, while that's going on, is in fact, if I come back to the services services tab. And on the MCR, we have what's called our MCR looking glass. So if you just click on that MCR looking glass, it'll take you to the actual routing table that is on the device. So, kind of this is the page that I had already loaded because it does take a few seconds for everything to load. So here we see kind of what we saw, before the change, where this 192.168, that's my AWS environment. And we are learning it with a med of 10 of 100, and we are actually using a next hop of 10.10.02. We can see those individual advertisements coming in though, if we go to our neighbor routes and look at the received. So we see the 10.10.02 peering. So this is the primary path of our /16. Through various mechanisms, it has been decided that this is our best route. And you'll notice the med. And then if we go to our secondary, you'll see this is not the best route. And if you do the breakdown, you see it is because of the med being 200. Higher med secondary is less preferred. So let's go ahead and reload this data. Let's just switch down here. Oh, awesome. So if you remember before, we actually saw just 10.10 and 10.10. Just basically with the way MTR works, let's just go ahead and cancel that out and restart it. You're going to see that the traffic has actually failed over to the 10.20 path. So by implementing that prepend and the med, we were able to influence traffic. We've successfully filtered off that primary path, the primary AWS peering. And now all traffic, if this were a production environment, we'd see all of our traffic swing over to that secondary path. And we'd see that primary link, or at least what's labeled as primary, should be just not taking traffic and actually, being in a state where you could filter it off and actually perform a maintenance on it and do whatever you need to do and not have to worry about it affecting customers. So, that ultimately that tool gives you a mechanism to be able to perform maintenances at the same time. Lots of other reasons why you might want to change over, if you are in an active standby state. But kind of the big takeaway there is just that tool is available to help you with routing as needed. In fact, let's go ahead and switch over to the Azure VM. Let's do that same trace route. So you can see previously we were going 10.10 as our first hop, going into the MCR. Now we're doing 10.20 going into the MCR. So, that we're successfully rerouting traffic as needed. So Azure, we didn't necessarily need to change anything on the Azure side. Just ultimately the MCR is handling that routing decision, deciding that traffic needs to take that secondary path. And honestly, Azure never cares in this kind of environment. Kind of another important thing to note is like in this demo, I had 2 connections going to AWS, single going into Azure, just make things a little bit simpler. But everything that we just did is completely applicable to an Azure environment as well. If we had 2 Azure Express routes configured, we can do these exact same manipulations on those Azure peerings as well. Same for basically all cloud peerings at the same time. If this MCR was connected to your on-prem environment and doing some routing there, again, end of the day, it's BGP, and you can use the same kind of mechanisms for that kind of route manipulation. So I'm going to be perfectly honest with you. I was expecting this route change to take a little bit longer than that. So, we've ultimately described it. So in fact, let's go ahead and say we're at post maintenance and we want to go ahead and shift everything back. So let's just go back in the portal and kind of redo our changes. So let's come back into the portal. In fact, I switched over to the looking glass. And actually, let's just go ahead and look at the looking glass. So now you're going to see the best path for getting to AWS has now switched over to the 10.20, which is our secondary. So you'll see the med right there. And if we go into our individual neighbor routes and our received routes, you'll see that now primary is no longer the best route and secondary is, ultimately because we've manipulated the med. So let's go ahead and undo those changes. So I'm going to come back over here to services. So here's our MCR. So we want to make our secondary non-preferred again. So we come in, go to our AN tab, go to our BGP connection, hit edit, advanced, and let's just put in our same configuration that we had before. So we're just going to do 200. In fact, I'm going to leave outbound med just to prove that that's not really having any effect here, and hit update and save. So once again, we're going to be waiting about 2 to 3 minutes for this change to take effect. Let's see. And at the same time, I do if in case you are a little bit unaware of med and prepend and all that stuff, it kind of goes a little bit beyond the scope of what we're talking about here. But if you do want to do a little bit deeper studying on the subject, this is a Cisco doc. Basically, you have your 13 step selection algorithm that's part of BGP. The way this ultimately works is, whenever your router is trying to decide which direction to go, it starts at the top, starts with wait, which is a Cisco proprietary, but then ultimately just goes through each step and then finds the best path. So here we start at wait. At wait's the same. Local pref is going to be the same between the primary and secondary. But when we get to step 4, we're looking for the shortest AS path. So ultimately, this is the step that the AWS side is going to use to make their selection. So AS path is going to see the higher prepended path and then select that as the best path. At the same time, if we had not done any kind of AS path manipulation, we get to step 6, and here's med, and ultimately lowest med wins. So if you want to take this a step further, just put in BGP best path selection algorithm. This is going to be the first search on Google. It's same Juniper, Arista, all the other vendors have essentially the exact same page with little changes here and there. But it's just something to look into if you're kind of curious. Let's go back, and looks like one of our hops has made the change. And so actually, as I was talking, I was kind of curious if it was going to happen or not. So I didn't change the med of the outbound med towards AWS. And I was actually kind of curious if this was going to happen or not. So I kind of mentioned that the best path selection algorithm, this is Cisco's best path selection algorithm. AWS may be using a device that's a little bit different, and for some reason, it might actually prefer med over AS path. So I really did accidentally make a mistake there, but it does prove a point that maybe AWS, so this is a trace route from AWS out, and then AWS is not failing over back to the primary because I didn't change the outbound med on the MCR. But if I were to come back in here and go to our connection and hit edit, advanced, if I were to go ahead and change this outbound med to a higher value, that and of course we gave it a couple minutes, we should see that traffic fail over too. We can just stick around for a couple of minutes here and see that happen, and just wait. In fact, let's just go ahead and kind of see the effects of that configuration on our advertisements. So one thing, another kind of important note here, whenever you're looking at your routes on the MCR, I don't fully understand why routers do this, but they actually don't show the prepend happening whenever you configure it. So on this, these are the two routes. I'm sorry, actually, this is the Azure route that is being advertised towards AWS. And if you look at your AS path, you're only going to see the Azure path. You're not going to see your prepends being configured. So that's something to be aware of whenever you're looking at this portal. Even though you configured prepending, you're not going to necessarily see it in this AS path. You actually have to get onto the neighbor device. You have to get into the AWS and look at the learned routes. And then from there, you're going to be able to see the prepended routes coming through. So let's go ahead and come back over here and see. We have not had a failover happen yet. let me just start the MTR. Yeah, so we still haven't failed over. Oh, just happened. So the pre-pin, sorry, we put in the med of 200, the higher med of 200 on the secondary route. So whenever that happens, the traffic failed over. Um, so yeah, didn't intentionally do that, but it was a nice little surprise there just to see that AWS apparently AWS prefers med over AS path in their selection algorithm on whatever platform they're using. So it's just something to be aware of whenever you're playing with this stuff. So yeah, that's kind of all I had prepared for talking about today. So yeah, I'll just, if you have any questions, reach out to Megaport however you want to. If you're a Megaport customer, reach out to your account team. And same time, if you want have some more questions here, just go onto the Megaport portal, clicking on the docs.megaport.com, do some research, and just reach out to us if you have any questions. So yeah, thank you for your time, and I hope you have a good weekend. Bye.